Say when. Okay, very good. All right, I'll be talking about Ingres NetStar and Gateway and how we fare relative to the competition and how to sell these products aggressively against the competition. Essentially what you'll see in this presentation is the truth of the matter is, although we often get Ingres guilt, the fact that we don't have all of the gateways available at this time, and we've been talking about them for some time, and all the access products out, relative to our competition, relative to what else is in the market, we're in much better shape. We are essentially competing with full functional products versus Sybase, which is offering a set of toolkits, and I'll talk about this, and Oracle, which is offering partially functional products. So relative to the competition, we are in a very strong position. And I think you'll see throughout this presentation. So I'm going to talk first about the market requirement for access products, and you can verify this as you walk to various accounts, what customers can you for. I will talk for products, Ingres and then Ingres Gate, what our agenda is, what agenda you want to set when you walk into an account in the customer is, what agenda you want to set when you walk into an account in the customer's minds, which will make the competition sell uphill against us. Then I'll go through each of our competitors, Oracle first, then Sybase, and a short bit of information on Informix. Bottom line, I've been in a fair number of accounts with, I'm not sure whether it's been with anyone in this room, but certainly out on a number of sales calls. And essentially, most customers are trying to solve a common problem. And the problem is unifying information within their organization. In most organizations, the MIS organization is chartered with the task of, within 3 to 5 years, coming up with a set of computers, networks, application software, databases, which will allow them to integrate information within their organization. And essentially, Oracle and Sybase and Informix and Ingres are calling on these same accounts, all with a story, essentially telling that MIS department or that company that they are able to provide access to distributed and multi-vendor information. So at a very high level, the first thing you experience in an account is that everyone in the customer's minds, we're not differentiated immediately. The customer's attitude generally will be, well, Informix is in here, and Oracle's in here, and Sybase is in here, and they're all telling me that they have a way to get to DB2 data, and they have a way to get to data located at multiple sites. So what's different about the Ingres solution? Well, the bottom line is, as we go through the Ingres solution, we are the only provider of full functional products on the market today that you can actually plug into your environment that provide immediate online access to information in other vendors' databases such as DB2 or in databases at multiple locations, for example through Ingres Star, through standard SQL. That simple statement, we provide products which you can install in your environment that provide immediate online access to data, is a differentiating statement. Because everyone else in the market is providing either toolkit technology where you have to build a server to provide that access, or partially functional products where you have to code applications to provide that access. Essentially, we provide three things: a full functional distributed database management system, and I'll tell you what I mean by a full functional distributed database management system. Our philosophy is to provide SQL access to all data. So whether it's relational data, non-relational data such as RMS or IMS, the Ingres solution is always to provide access through SQL. That is not true of all of our competition. And we offer that capability by the fact that we provide gateways that translate differences between Ingres and non-Ingres databases. We'll cover that. All right, let me talk about distributed database first. And I want you to keep this agenda in mind. This is not in your notebook now, but I would appreciate it if you write it down. Anytime that you go in an account and you talk about distributed database, you should set the following agenda in the customer's mind. What distributed databases are about is they're about making it easy to get to data throughout your organization. There are three things which distributed database management systems must do. They must make it easy to unify information within your organization. That is, extract information from different vendors' databases at different locations and provide it efficiently to the user. 1. 2, distributed database management systems must be able to distribute data and distribute updates. And the critical technology here we'll talk about is automatic two-phase commit. In other words, the distributed database management system has to be able to keep data at multiple sites consistent for you. And the third thing that distributed database management systems have to be able to do is make it easy to manage distributed data. Now the reason we set this agenda at ends up is because it's an agenda which makes our competitors sell uphill. And it's an honest agenda. This really is what distributed database management systems must provide, a simple encapsulation. To do data unification, to bring data from multiple sites together efficiently, the critical technology that has to be provided is a global optimizer. So keep that in mind. Data unification, global optimizer. To be able to distribute data, keep data at multiple sites consistent, the distributed database management system must provide automatic two-phase commit. And finally, to make it easy to manage distributed data, the distributed database management system must provide a global data dictionary and DBA tools that work with that global data dictionary. Now this is important because when you set that agenda, what you're doing is you're setting your competitors up for failure. Okay, let's talk about data unification. There are really three aspects to this. And remember, the thing that you want to emphasize with data unification is global optimization. But I'll cover the first two. First of all, we make it easy through our OpenSQL architecture to get to data which is located at multiple sites in different types of databases. Ingres star, think of Ingres star this way. Ingres star locates data for you. Once you construct a distributed database, you essentially indicate to star where data is located and what local databases. Subsequently, any application which sends SQL queries to the distributed database management system, it's up to star to determine where that data is located. Star does the work for you of determining the location of data. That's how it provides location transparency. Secondly, star works with our family of gateway products, which make all databases look like Ingres databases. Hence, by star working with gateways, star provides not only location transparency but also database transparency. We, as you might have noticed on email, we recently ran a access seminar both in Boston and in Santa Clara where we actually demonstrated a Macintosh sending an SQL statement to Ingres star, which then performed a distributed join between DB2 and Ingres and returned the data back to the Macintosh. That was through the GQL product, and presented the information in a pie chart form. So that product is in demo status today. We can actually demonstrate it. The thing you want to emphasize with with data unification is global optimization. What is global optimization? Dave Kolau speaks quite a bit about optimization and its importance in database management systems. Optimization is all the more important in distributed database management systems because there are communication links involved. And in a network, the communication link or the network is the slowest point. It is the bottleneck in the entire system. What global optimization does, what star does through its global optimization feature, is essentially it thinks before it acts. If you need to extract information from multiple locations, you send an SQL query to star, and star does the work of determining the quickest way to get the data back to you. And the way it does that is it maintains statistics about the relative distribution of data, how much data is at what sites. It looks at the query that you've sent it, and it constructs a number of plans of how it might go about getting the data. It selects the most efficient one, in other words, the one which will result in the least amount of movement of data across a network. And then it executes that plan. As an example, let's say you wanted to find out how many US citizens worked for GM Corporation, and it ends up that you work in personnel and you actually work in the Taiwan unit of GM, which makes some of the cheap ashtrays that go in the cars. Well, it ends up in Taiwan, there are only 10 US citizens working for GM Corporation. But back in Detroit, and maybe this is a few years out, there's on the order of 1 million people working for Detroit GM plant. Well, it's very important that the global optimizer knows to send 10 records across the Atlantic to the GM site perform the join at the jam site and send the result back, which says whatever that result is, as opposed to moving 1 million records across the Atlantic, performing the join at the local site, the Taiwan site. In other words, it looks at the two different ways that it can perform this distributed query, and it selects the one that's going to result in the least amount of movement across the network, because that's going to be the quickest. Star always determines the quickest way to get the data for you. So to do data unification efficiently, a global optimizer is required. And neither Oracle nor Sybase provide a global optimizer. Actually, the global optimizer is much smarter than just looking at the relative amount of data at various locations. If it ends up that a distributed query refers to approximately the same amount of data at 2 different locations, then Ingres Star will look at other factors to determine the quickest way to get the data back to the user. It'll look at such things as the availability of indexes on various tables at different sites. It'll look at such things as the storage structure, and also system factors such as the relative CPU power of the participating systems. So it's a very smart global optimizer. Okay, so that's data unification. 3-point agenda. First point, data unification. And you absolutely have to have a global optimizer to do data unification in an efficient manner. Secondly, data distribution. The second job of distributed databases is to keep data at multiple sites consistent for you. And that requires a feature called automatic two-phase commit and a couple of other related features. Okay, I'm not going to dwell on this, but we do support transactions in a heterogeneous database environment. We're still waiting for the certification of Star against gateways. That's coming. And the point is that we provide a distributed transaction facility which will allow you to read information from Ingres or non-Ingres sites through Ingres gateways and update either an Ingres or a non-Ingres site. So we support distributed transactions which provide single site update where Ingres and non-Ingres databases are supported. Better than that, where Ingres databases are supported, we provide automatic two-phase commit, which allows the distributed database management system to keep related data at multiple sites consistent for you. The two-phase commit protocol is often exemplified by a marriage ceremony. So a marriage is a two-phase commit ceremony. Essentially, in the marriage ceremony, there is a coordinator, the minister, and there are participants, the to-be husband and wife. And essentially, just to explain the two-phase commit protocol, it's up to the minister to first check with the husband whether he wants to get married to this woman, and with the woman whether she wants to get married to the man before he pronounces them man and wife. Now, if either of them back out of the ceremony prior to that point, in other words, the wife says, well, I've been thinking about it, and this guy is really a schmuck, and I think I better not go through with this ceremony, and she says so to the minister, then the minister will abort the ceremony. Likewise, if the fellow backs out. If they both indicate that they do want to get married, then the minister commits to completing the ceremony. Now, the point is, Ingres Star handles checking to see whether various databases which are to be updated are available to be updated prior to updating them. So the two-phase commit protocol, in other words, checking to see that sites are available to be updated before they're updated, is handled by Ingres Star itself. You, the user, or the application simply send a transaction to Ingres Star, and Ingres Star handles two-phase commit automatically. Now, in the scenario I just gave you, well, actually, let me first indicate why this is important. There is an entire range of applications which require automatic two-phase commit. You can refer to these as all or nothing applications, where what you have to do is you have to update related information at multiple sites as a logical unit or not update it. It has to all be updated or all not updated. And a simple example of this is a multi-branch bank transaction. Let's say you want to withdraw some information, some money, which you have in your savings account, and credit it to your local checking account. Savings account is located at the main branch and your checking account at the local branch. So essentially, you, the customer, send a withdrawal transaction to Star, and Star checks to see whether the savings account can be debited and whether the checking account database can be credited. Now, it's not sufficient for it to debit savings and not credit checking, or credit checking and not debit savings. Clearly, the latter, for example, would result in a costly error for the bank. What is required is that either both savings is debited and checking is credited, or neither are debited or credited. And Ingres Star, by sending a transaction to Ingres Star would make sure that either both happen or neither happen. That's what two-phase commit is about. Now, back to our marriage ceremony, what happens if after the man and woman both agree that they want to be married, somebody shoots the minister? Somebody has to, so there's some disgruntled left-wing person in the church that doesn't like religious ceremonies, and so he decides to shoot the minister, and it so happens that he shoots the minister right after both the man and woman indicate that they want to be married. Okay, someone has to recover the situation. They both want to be married, yet the minister hasn't pronounced them man and wife yet. So, what to do? One thing that could be done is you could bring in another, you could drag out the first minister and bring in another minister to complete the ceremony. You'll have to excuse the morbid example here. Now, Ingres Star actually can operate in this mode. In other words, since it is possible to locate Ingres Star at multiple points within your network, in other words, you can locate Star at multiple points within your network and have different Star servers serve the same distributed database, such that if one computer with Star becomes unavailable, another computer running Star can kick in and finish the distributed transaction. We actually support that capability today. Now, that essentially is analogous to bringing in another minister and completing the ceremony. The second failure that can occur is a disgruntled girlfriend in the audience may shoot the to-be husband. And this is, so at this point, the husband has indicated that he wants to be, the to-be husband indicated that he wanted to be married, and the to-be wife that she wants to be married, and then somebody shoots the husband. Well, how do you recover that situation? Now, let's say in this case he's not he's not fatally wounded. He'll recover eventually. This is what's called, in technical terminology, a participant failure. And or there's another technical term, which is the disgruntled girlfriend failure. In this case, Star utilizes a feature that it release 6 Star contains called automatic recovery management. What automatic recovery management does is it recovers the situation of participant failures. So, if Star checks to see whether database 1 is available and it says, yes, I'm available to be updated, database 2, yes, I'm available to be updated, Star decides to update both databases, and then database 1 fails. Now, Star has decided to update both. It proceeds with the update. It updates the available database. It fails to update the unavailable database. It logs the fact that it is unable to update the unavailable database in its distributed transaction log. And then it uses a retry loop so that when the failed database recovers, it automatically applies the update to the failed database. That's what automatic recovery management is about. It ends up that there's actually quite a bit more to automatic recovery management, and if you want to get information on the technical details, there actually is a tape which explains how Star recovers all cases of failure, of which there are 3 types: database, network, or computer failure, which can occur at several points within a distributed transaction. But the point is, star takes care of all of these cases to ensure that all available data is consistent. If you have a failure, you don't have to worry about data at multiple sites being consistent when that database recovers. Star will take care of it for you. That's what automatic recovery management is about. Okay, and I should mention that that is a unique feature of Ingres star. None of our major competitors have automatic two-phase commit or automatic recovery management in their database management systems today. Oracle's working on it. Sybase, who claims two-phase commit support, does not have automatic two-phase commit support. They have programmatic two-phase commit support, and use that term with your customers, which means that you have to explicitly code the two-phase commit protocol within your application. The database management system doesn't do the work for you. And secondly, Sybase does not provide automatic recovery management. So with the Sybase solution, you have to write your own recovery manager. They're giving you the two-phase commit primitives only to code within your application. A lot of work, whereas we're providing a product which does all the work for you. Okay? Okay, third area now, database administration, distributed database administration. The critical technology that vendors must supply to make it easy to manage distributed data is a global data dictionary and tools that work with a global data dictionary. We do this, and essentially what we do is we make all dictionaries that participate in an Ingres star distributed database look like the same type of dictionary. We do this, you can read about it through a feature called Common System Catalog. So we make all dictionaries look like the same type of dictionary, and then we offer the ability to combine these dictionaries logically into a single logical dictionary for your organization. And because we do that, and we offer a tool called StarView with Ingres star, we provide a way for you to manage distributed data from a single desktop through a pop-up window interface through this DBA utility provided with Ingres star called StarView. And as you'll see later in the presentation, that is quite different from what our competitors provide, where you have to go to each system within your, quote, distributed database and administer it separately. So you get top-down administration capability with Ingres star only. I talked about redundant server failover in the context of distributed transactions. This applies equally well to distributed queries. So it ends up that if you're collecting information from your accounting and your manufacturing department through Ingres star, in other words, executing a distributed query, and one computer fails, your application can connect to another Ingres star server, which is maintaining the same distributed database, in other words, the same set of local data, and continue with your distributed query. We thereby, through this feature, offer a fail-safe operation of distributed database.
Can you have two? Does that mean you have both of those star servers running simultaneously, and some nodes are using one and some nodes are using the other?
You could set it up that way. This particular picture is really that you have a backup server, which is there only for failover purposes. But you could, yes, the scenario that you just described is perfectly possible. Yeah.
To understand in this case, then you're sending each, this you mentioned query, you're sending the query twice, once to each server?
No.
Simultaneously to both servers?
No. You're sending, in this case, you are sending a query to one star server, and the star server is collecting the data for you and sending it back. In the case where that star server fails, you're then able to connect to another star server, send the same query to it, and it will perform the same operation for you.
So you'd have to reinitiate and re-execute?
Yes, but you could write your application to handle that for you. It would simply, essentially, when a star server failed, a message would come from our communication facility, global communication architecture, which can be handled by the application to take the action of establishing a connection to another star server and continuing the distributed query. Okay?
So, do both, if you have two servers floating around, then they keep each other in sync, or?
Okay, this is, yeah, right, this is a good question. The cost, there is an administrative cost associated with having more than one star server in your network. And that is, if you want 2 or more star servers to maintain the same set of local data, the same distributed database, you have to make sure that the global data dictionary is staying in sync. Because there's one global data dictionary per star server in our current architecture. Once again, you can handle this, you can automate this today simply by writing a process which is executed at a specified time, a daemon process, which copies the contents of one global data dictionary to the other periodically. Secondly, with the automatic two-phase commit capability, you could actually write your application so that you never change data dictionary information except as a part of a distributed transaction, so that system catalogs at different sites are always all updated or not all updated. Okay, okay, so in summary, this is the distributed database agenda. This is the STAR agenda. When you talk to customers about distributed database, you should set in their mind that what they need to do is collect information from multiple locations, and I think they'll agree with you, keep data at multiple sites consistent, and manage this distributed data. Distribute, unify, distribute, manage. The critical technology involved with data unification is global optimization. And yes, Ingres provides a global optimizer. The critical technology involved with data distribution is automatic two-phase commit and recovery management. And we provide those two features. And the critical technologies involved with managing distributed data are global data dictionary and then tools like StarView that work with the global data dictionary. And we provide that. So in the three-point agenda, we score 3 points, and our competitors, as you'll see, score 1 to 0. This is not a fudged agenda either. We get lots of support from all the experts in the distributed database field that essentially distributed database functions break down into these 3 areas: distributed queries, distributed transactions, and distributed database management. And even such capabilities, advanced capabilities such as copies and fragments. Fragments really falls into the unification area, and copies really falls into the distribution area. So this 3-point agenda works quite well. Okay, I'm going to talk for a couple minutes about Ingres gateways and how we compare with our competitors. But first, I'd like to ask if there are any questions about Ingres Star or Ingres Star competition. I'm going to cover Sybase and Oracle competition in this area in more depth.
You said there was a video tape that went into a lot of detail on the
Right.
technology and stuff.
Right. There is a tape called Overview, Technical Overview of Ingres Star Automatic Two-Phase Commit.
Where can we get the tape?
You can get a copy from Meg. You can get it from Meg.
Say that again, what was the name?
It's called an overview, Technical Overview of Ingres Star Automatic Two-Phase Commit. And Meg Collins will give you a copy. Okay? Okay, gateways. Essentially, what gateways are about are getting to other vendors' data. So if you're an Ingres user and you need to get to DB2 data, or you're an Oracle user and you need to get to RMS data, you need a gateway. And there are really 4 problems involved with getting to other vendors' data. The first problem is different vendors' databases understand different query languages. Even if they're SQL databases, not all vendors' implementations of SQL are the same. Therefore, you have to provide something which translates between your application, the SQL that your application is using, and the SQL that the database is using. You have the same problem with data types. Different vendors' databases understand different data types. Different vendors' databases produce different error codes for the same error conditions. And data dictionary information is stored differently in different vendors' databases. Now, the point of gateways is to make all information look like it's of the same type of database. somebody or something has to translate these vendor differences. And the bottom line in the gateway world is either you translate the differences within your application, or you buy a product which translates the differences for you. And we're providing full functional gateways which translate all of these differences for you, so that the way that you get to DB2 data or RMS data or IMS data is always the same. It's through a single query language called OpenSQL. Now there are other types of gateways in the market. There are actually two other types. There's the type that Oracle provides, which I like to call a pass-through gateway. And essentially, a pass-through gateway allows you to connect to a foreign database. So if you are running an Oracle application, you need to get the DB2 data. Oracle supplies a product called SQL Connect, which allows you to connect to DB2. However, that product, SQL Connect, doesn't do any vendor translations for you. So in your Oracle application, you now have to write DB2 SQL code, handle DB2 data types, handle DB2 error messages, etc., to get to DB2 data. Whereas remember, the Ingres solution allows you to send a single version of SQL, the same that you would use against an Ingres database, to a DB2 database or an RMS file system, and not have to worry about any of these translations within your application. So pass-through gateways are partially functional gateways which require a lot of work on your part to get to other vendors' data. And Oracle actually provides two varieties of this. It ends up that tools like SQL Forms, this is a good gotcha to bring up with customers. SQL Forms does not work through SQL Connect against foreign databases. So you can't run SQL Forms against the DB2 database just using the Oracle SQL Connect gateway. What you have to do is you have to put an Oracle database into your picture, because SQL Forms requires information in the Oracle Data Dictionary. And Oracle doesn't support a common dictionary format as we do through common system catalogs. So for certain tools, Oracle actually requires you to install an Oracle database on, for example, your MVS system, and then an Oracle SQL Connect product to connect to DB2 to use SQL Forms against DB2. That's pretty messy. You already have DB2 running over on your mainframe, and you have to install an entire Oracle database as well as the SQL Connect product to run a product like SQL Forms against DB2. That's a fact. Okay.
So the native database actually issues SQL or DB2 native commands to it in order to pull information back into the Oracle database and then turn around and feed it back to the form?
Well, what is happening is essentially you still have to write in DB2 SQL. So the Oracle database is not doing any vendor translations for you. You have the same problem that you have with the SQL Connect product. It's just that you have to have the database there because SQL Forms requires information which is in the Oracle Data Dictionary for it to run. It stores forms, information, etc. In the dictionary. Yes?
Okay, so that would mean that if you're going to use SQL Forms to go against a DB2 application, that somehow you've got to get into the SQL Forms application and change the SQL in there to DB2 SQL?
That's correct. Yes. Absolutely. You have to do the translations within your application. The only thing that Oracle is supplying is a connection to DB2. Now, with Sybase, it's even worse, because not only do you have to do all these translations, but you actually have to build the gateway. What Sybase is providing is a toolkit which allows you to link code into the foreign database. So let's take the case of DB2. They provide you a set of source code which allows you to link source into the DB2 process so that you can store procedures at the DB2 site, which you can call from either a Sybase server or a Sybase client. It's a write-your-own gateway solution. They're not providing any product that you can install and access foreign information through standard SQL. The other big problem with this solution is that your access to foreign data is not through standard SQL, it's through database procedures. So essentially, you store a set of procedures up at your DB2 site, and you send procedure call names and associated parameters to the DB2 site. It executes the procedures against DB2 and downloads the information to your Oracle, to your Sybase server or client application. Yeah.
So you're saying if I have Sybase running on my Sun and I want to access some DB2 data, I can't write an SQL query as a user to access the DB2 database?
You write a database procedure and you store it at the remote site, and then within an SQL application you call the procedure.
Okay, so I just basically can't write
You cannot
an
use.
ad hoc SQL query from that Sun to the
No.
IBM main.
No, you cannot. This also means that you can't take a standard off-the-shelf tool and run it against DB2 through the Sybase solution, because the gateway only understands a predefined set of operations against the foreign data. What you can do with that DB2 data is delimited by the procedures which you've written to work against DB2. Okay, so let's summarize this. Essentially, for data unification, global optimization is required. Ingres provides it, Oracle doesn't. Sybase does not. Informix does provide a global optimizer in the Informix Star product, which is not full functional. It does offer some capabilities, it just is nowhere as sophisticated as an Ingres optimizer. It doesn't take as many factors into consideration. Two-phase commit. Yes, we provide automatic two-phase commit with recovery management in Ingres Star. Oracle does not provide two-phase commit today. They are promising that they will provide automatic two-phase commit in their next release of their database, which is release 7. Sybase provides two-phase commit, programmatic two-phase commit, which means that they give you the primitives to allow you to write within your application the two-phase commit protocol, and you have to handle any cases of failure to recover data into a consistent state should a computer fail or network or database. And Informix provides no two-phase commit capability whatsoever. Yeah.
The Oracle marketing literature here states that Ingres has a programmatic two-phase commit.
What you have is a slightly older version of their marketing literature, and they're probably still sending it around knowing Oracle. But it was true that we first came out with programmatic two-phase commit in 6.3, which allowed you to code the two-phase commit protocol within your application before we came out with two-phase commit support in Star. So when we came out with Intelligent Database, one of the features we came out with was programmatic two-phase commit. Subsequently, we came out with automatic two-phase commit in Ingres Star. So that's just outdated.
So
Yeah. Okay.
if you have 6.3, then you have programmatic two-phase commit. If you go, so if a system doesn't have Star yet released there, you don't have automatic two-phase commit.
That's correct. You have no two-phase commit prior to 6.3. If you have 6.3 base product, then you have programmatic two-phase commit. If you have 6.302, it ends up Ingres Star on your platform, which is currently only available on VMS, then you have automatic two-phase commit.
They also say that we don't have a manual override. What is that?
I think they're referring to some commands they support to build a recovery management system. Basically, the answer to that is recovery management is taken care of for you by Star with 6.3 Star. What they are doing is comparing our programmatic two-phase commit to I'm not sure exactly what they're comparing it to. Maybe they're comparing it to some primitives that Sybase provides.
Does non-block server mean anything to you?
Non-blocking I/O. Okay. I don't want to get into technical details at this point, but I'll talk to you afterwards because we need to move along here. Okay. Database administration, global data dictionary. We provide a global data dictionary with DBA tool, StarView. None of our competitors provide distributed data management capability. SQL access to all data. Sybase does not provide that. For example, to get to non-relational data through the Sybase system, you actually have to code the non-relational query language. If, for example, you're getting to IMS data or RMS data, you have to use RMS file calls or IMS DL1 calls. We're the only vendor that provide full functional gateways which actually translate these vendor differences for you. Okay. Well, I've hinted about how, in what bad shape the competition is in. What is it that Oracle is saying when they walk into an account today and you're competing, you're essentially competing on an access cell? What Oracle does is, Oracle realizes that they have a weak product relative to our current offering. Therefore, what they do is they concentrate on selling their future. They concentrate on selling Release 7. Because Release 7 is the first Oracle release which will have some significant distributed database capability. It will include automatic two-phase commit. In general, when they're asked about advanced features like copies, etc., the Oracle salesperson's answer is it's in Release 7. You may call it Release 7 heaven. I mean, everything that is not in the current Oracle product is in Release 7, is the answer. Oracle also stretches the truth to the point of just lying. They claim that they have transparent gateways. Well, the bottom line is their gateways don't translate these vendor differences, therefore they're not transparent. They claim that they have read-write gateways. All the information that we have, and we've competed in some accounts we have our gateways installed where Oracle gateways are installed in that same account, and we have not yet seen an Oracle read-write gateway. All of their gateways, regardless of what they say, are read-only.
Is that something you can actually tell a prospect? I mean,
Sure.
they actively market that they're read-write gateways and everything in all their gateways, or?
They both market them as fully transparent gateways and read-write gateways. And we have not yet seen a read-write gateway. So I would push that with the customer, yes. We're always glad to be educated. If they happen to have a read-write gateway, then let's see it. We have not seen one yet. Two-phase commit, automatic two-phase commit, it is coming in Release 7. That's a reality. They've been working on it for some time. They can demonstrate it. They talk about having replicate support, copies support. What they mean is that they're able to run an SQL script which is able to copy data through SQLnet from one site to another site. That is not copy support, but they market it as copy support. Oracle will almost inevitably, if they're competing with you in an account where star is brought up, they will charge that star has a single point of failure. That's their favorite slogan with respect to star. And you've just seen that star doesn't have a single point of failure because you can simply configure multiple star servers within your network which manage the same set of local data. There is some administration costs associated with that, but by no means does Ingres star have a single point of failure, or has it ever had a single point of failure. And they also paint this picture that Oracle tools work with gateways. Well, as I just indicated, that's not true unless you install an Oracle database everywhere. Then all their tools will work with their gateways because their tools require information in the Oracle data dictionary. So one tack that you want to take with Oracle is you can count up front that they're stretching the truth to the point of lying about their capabilities, and simply call them on it. Be educative. Help the customer understand that when they say we have transparent gateways, what they mean is, well, not really, because they can connect to other vendors' databases, but you do have to get it right down to a reality level. You do have to actually translate these differences within your application. Oracle's product today is extremely weak. They don't have a true distributed database management system. They have a facility within their local database management system called synonyms, which essentially tells the database management system, oh, the data is not located at this node, it's actually located at a remote node, use SQLnet to go get it and bring it to the local node. That's not a distributed database management system. It's just a set of local database management systems which are connected through communications drivers. Because they have this architecture, they have no central intelligence node within the network like Ingres star, which knows about the relative distribution of data across the network. They're unable to do global optimization. They're also unable in their current architecture to update multiple remote sites. I'll talk about that in a minute. And their synonym architecture makes it very difficult to manage data at multiple sites because there is no global data dictionary. You have to actually go to each individual Oracle site and manage the local dictionary. That's how you do, quote, distributed dictionary management. As I mentioned, they have a set of gateways, their SQL Connect product family. They're not transparent gateways by any stretch of the imagination. And they do have a good product with SQLnet. It's their only strong product. That is the equivalent of our Ingres Net. Although it is not based upon industry standards, it is not based upon OSI, for example. Yes?
Can they do a distributed join? I mean, with like a DB2 database and an Oracle database? You just said that you have to write, it's not transparent, you have to write native DB2 SQL. Can they write a join like that against two databases?
Well, the funny thing, it's funny that you say that because at all of their seminars, they, quote, demonstrate a distributed join between a PC. It's actually a three-way distributed join between Oracle on a PC, Oracle on a VAX, and DB2. And the bottom line is, you're right, they don't provide a single query language which can be understood both by DB2 and by Oracle. In cases where, so they would have to select a query which is equivalent both in Oracle and DB2, first of all, for this to work. And there are a fair number of them because Oracle based their SQL on DB2 SQL. It's fairly close. So yes, they can do distributed queries with those restrictions. They don't do them efficiently because they do no global optimization. So their architecture essentially looks like this. In the case of a distributed query, distributed join, let's say they wanted to join tables at these three sites, A, B, and C at each site. They would send the query to the first site. The Oracle database would have two synonyms at the first site indicating that table B is on node 2 and table C is on node 3. Go get B at 2 and C at 3, bring them to node 1, and build temp tables for B and C and perform the join between A and temp table B and temp table C. Okay? Well, so they can do it. But in any real scenario, it would be extremely inefficient because they're not doing any global optimization. They're moving all of this data back to the original node. They do, to their credit, I'll say that they later introduced being able to send as a part of that query, a where clause to the remote site so that they do move the qualified data back. That is not all of the data in a table back, but the data is qualified by the where clause back to the local site. Still, they are not able, if the result of a subquery and a distributed query is a lot of data at one site and a little data at another site, they're not able to determine whether they should move information from A to B or B to A. In other words, they're not able to do any global optimization. They can't do global optimization in this architecture because there is no central node which maintains information about the relative distribution of data. Secondly, they actually cannot update remote sites in a synonym architecture. Believe it or not, as a part of a distributed transaction, they can only update the site to which the client originally attaches. It's a restriction in the way that synonyms are implemented. And finally, administration is a mess under this architecture because you have no global data dictionary. Essentially, what you have are these synonyms which point to other nodes, and so you have at every node synonyms that point to other nodes. Multiple synonyms at every node. That means that if you add a table or drop a table to your, quote, distributed database, you have to let every node in your network that's participating in this distributed database know now that there's another node with another table that's supposed to be a part of this distributed database. As an example, I gave you the example of node 1, 2, and 3, tables A, B, and C. Let's say you wanted to add table D at node 3. Well, now you have to make changes both at node 1 to indicate that there's a synonym for table D. So call it synonym foo1 at node 1, which indicates that there's a synonym for a table at D at node 3. And you have to go to the second node and create another synonym at the second node indicating, so call it foo2, indicating that there's table D at node 3. That's an administrative headache. You have to go to every individual node and constantly maintain these synonyms. Okay, we talked about distributed queries. The problem with Oracle is Oracle always dumbly moves all information to the site which originally requested or generated the distributed query. And in certain cases, that can result in terrible performance. The point of Ingres star is that Ingres star will always look at the relative distribution of data, and regardless of where the data is or where the application is, will always choose the way to execute the query, which results in the least movement across the network and therefore the most efficient information collection method. I talked about this. In the cinnamon architecture, you can't update, believe it or not, multiple remote sites. Oracle is out hyping up the fact that they support copies or replicates. And the bottom line is the only thing that they're offering is the ability to write a SQL script which is able to select data from a remote node and copy it to another node. That is not a copy. Oracle's general tact is to talk about their next release, where they will have, for the first time in their entire history, some significant distributed database functionality. They will have essentially automatic two-phase commit and recovery management, to their credit. I don't know if and when they will ever have transparent gateways, because they don't have the architecture in place to provide an OpenSQL. They would have to actually re-architect their product to provide something analogous to OpenSQL, which is a single query language which allows you to access data in different vendors' databases. Likewise, they would have to re-architect their product to provide global optimization, because they would have to come up with a process which is able to maintain information about multiple local databases. They don't have any such process. So it's unlikely that they're going to offer transparent gateways or global optimization in the near term, which means it's a real opportunity for you to push these capabilities of Ingres. Oracle is not with any probability going to have them soon. They do not have a global data dictionary. It requires re-architecture again. What they have is multiple local dictionaries. And I actually heard Gordon Smith, who is the SQL Star product manager over at Oracle, make the claim in a public talk that Oracle has a global data dictionary. It's a fully partitioned global data dictionary, by which they mean they have multiple local dictionaries. So they're really shameless. And it's unlikely they'll provide, just in general, the level of multi-vendor interoperability that we do, because they have to re-architect. Okay, before I move on to Sybase, any questions about Oracle architecture?
Is the fact that they're running LU 6.2 and we're on 0 significant? And if not, why not?
One of Oracle's few strengths is that they support more protocols than we do. And they support, especially in the IBM arena, they support LU0, they support LU2, they support LU 6.2 on a number of platforms. What is the significance? The significance, first of all, users in an IBM environment don't really need to know how it is that they connect their, that they're able to run client-server between IBM and non-IBM systems. So it doesn't matter from the user standpoint whether it's LU0 or LU 6.2. All they know is that they can run an English application on VMS and access information in DB2. But what LU 6.2 does by a user and by Ingres, and the reason it is a direction of ours, is it is IBM's direction for application layer connectivity. We currently support LU0 between VMS, VM, and MVS. So we allow the ability to run an Ingres application on VMS and get to VM databases, SQLDS, or MVS databases, DB2, through LU0. We will eventually provide LU62 connections because then we can connect via IBM's standard connection protocol over a greater number of platforms. Because LU62 is supplied by various vendors on DOS and OS2, and there are some implementations available on Unix, whereas LU0 is quite restricted. It's just available on a few IBM platforms. So I rambled on a bit there, but the bottom line is LU62 is our direction for IBM networking support. In the meantime, we have LU0, which allows us to connect between VMS, VM, and MVS.
It doesn't support connectivity with Unix, you're saying?
No, because LU0 is not available on Unix.
So how do we connect up with
TCP/IP.
So you can run both of those?
You run TCP/IP on your mainframe and on the Unix system. And that's currently in beta, TCP/IP for MVS. Okay? Okay, questions about Oracle? No? Any disgruntled people in the back that want to make nasty comments or add to the general store of knowledge? Okay. Just interrupt me if you have questions or comments or criticisms.
Do you have any limitations connecting up PCs to this whole scenario?
Our limitations, by and large, are protocol limitations. So today we are able to connect. We do support TCP/IP on PCs, and that is the primary way by which we connect PCs to other Ingres platforms. So in the pictures that I've been presenting to you, the client application could be a PC, could be running on a PC. Okay, Sybase. What does Sybase tell the world? When you're competing with Sybase on an access sale, and Sybase has been talking to the customer, what have they been saying? Essentially, they're painting the following vision. It's the open server vision. And what open server is essentially a toolkit by which you can custom build an access solution. Now, Sybase, being an incredibly good marketing outfit, so good at marketing that they've successfully positioned themselves as the technology company when they're really just a darn good marketing company. They position their toolkit as an advantage because you can customize your access. Well, actually, it's quite a disadvantage because you have to do what they mean is you can't simply install a product and provide users immediate online access to other vendors' data or to distributed data. You have to build and modify servers in order to provide access to data across your organization. That's a lot of work. You have to be a system programmer. You can't be a user and install these products and gain access to distributed information. Sybase's entire solution is based upon database procedures. So the way that you get to data at multiple sites or in other vendors' databases is by coding database procedures and calling them from either a client application, or you can have a Sybase server call a database procedure at another Sybase or non-Sybase server. So Sybase's vision is the open server vision, which means build it yourself and use database procedures to get to data located at multiple sites and in different vendors' databases. Well, is that good? Actually, it's pretty bad because that means that you do not have SQL access to corporate data. You cannot get to distributed data through standard SQL. You cannot send a single SQL query to a Sybase server and have the Sybase server determine the location of data and bring the data from multiple sites back to you, the user. It won't work. What you have to do is you have to build a bunch of procedures which collect information from multiple sites and move it to a single site and combine the information. We'll talk about their data unification solution. But the bottom line is you have no SQL access to distributed data. You have no SQL access to non-relational data. So if you want to get to IMS or RMS data through Sybase, can't do it through SQL. Cannot do it through SQL. You have no dynamic SQL capability. Somebody brought this up earlier. You can't simply send an ad hoc query to an RMS file system through the Sybase solution. The system does not provide efficient access to distributed data because it provides no query optimization. You have to build everything yourself. They're providing you a set of technology to build the solution yourself. They're trying to position that as an advantage because you can customize your own solution. But in most cases, it's really a disadvantage because it means you have to do a lot of work to provide any sort of solution. As we talked about, it's hard to administer their solution because everything is based on database procedures, and if the location of data changes, since the location of data is hard-coded into your database procedures, you actually have to recode your database procedures to indicate the new location of data. So you're constantly recoding. It's hard to manage. And their whole solution is based upon Sybase technology, not upon any industry standards. It has nothing to do, first of all, their SQL is actually quite non-standard. And their database procedures are not standard by any stretch of the imagination. They call them remote procedure calls, but that's just a marketing play. They have nothing at all to do with industry standard remote procedure calls as supplied by OSF. They are Sybase proprietary remote database procedure calls. And the solution is not based upon OSI standards as ours is. Now, what Sybase does is they take their solution and they push the two things which are good in any respect about the open server solution. Those two things are that you can write procedures so that server events cause server events. I'll talk about what that means. Or servers can access non-database servers. So an example of the first is that you send you execute a procedure in a Sybase server, and you can set that procedure up to execute another procedure in another Sybase server, so that a number of things happen automatically. Okay? It ends up that there's a problem with that, and I'll talk about it. The second, servers access non-database servers. Sybase likes to use the example of inventory level falling below 10 for widgets in some company. And when it falls below 10, you can set the Sybase server up such that it automatically sends mail to somebody to tell them to reorder widgets. So Sybase server events can cause non-database server events to occur. In this case, a Sybase server is causing a mail server event to occur. In other words, sending somebody mail to reorder inventory. But how do you sell against Sybase? Basically, what I would suggest is take the short list that we saw and neutralize their solutions, because they may have some advantages and they may not. And I wouldn't dwell on this, but it ends up that you should point out that their, quote, advantages that they're touting are not clearly advantages. There are problems with their two advantages listed. Secondly, create buyer resistance. By that I mean point out that Sybase is non-standard. The direction of the industry is to provide SQL access to distributed data and SQL access to multi-vendor data, not database procedure access. That's Sybase's solution. That's not standard. Do you, Mr. or Ms. Customer, want to implement a solution which is non-standard? That's what you're talking about if you want to go the Sybase direction. So they're not a safe buy. And finally, take the long list we saw on the left, all the things that Ingres can do that Sybase cannot do, and push that with the customer so that Sybase sells uphill against Ingres. We should not be selling uphill against Sybase. They should be selling uphill against us.
According to who is SQL non-standard? Is that the SQL access group?
Well, it's a number of industry standard efforts. For example, ANSI SQL does not specify database procedure access. It specifies SQL access to vendors' data. Also, the emerging communication standards, the standard client-server protocol that's emerging is RDA, which our GCA is based upon, not Sybase's tabular data stream, which is completely proprietary. So when you investigate the Sybase, and there's some information in your booklet about the Sybase solution, it has nothing to do with the industry standards, ANSI SQL or ISO RDA. So it's non-standard, it's Sybase. Okay, let's take the two, quote, advantages that the Sybase people tout. The first one is the database events can cause, server events can cause server events. So the example I used is you can write a procedure and store it in a Sybase server such that when inventory falls below a certain level, say 10, it'll automatically send mail to a user to reorder that inventory. And Sybase says, isn't this great? Don't you want to do this? Ingres can't do this. Okay, well, not exactly true. First of all, we have a way of doing this. We can handle it through our application, and it ends up there are some advantages to this way. You can write an application which occasionally polls a database, and when inventory falls below a certain amount, have the application send mail to the user. Furthermore, by doing it through the application, you can do it in an industry standard fashion. In other words, you could use, for example, X.400 mail server protocol to send mail to the user. Whereas look at the Sybase case. What Sybase is saying is, okay, all right, you can set it up and make it automatic with the Sybase solution, but you actually have to modify your mail server. In this case, your X.400 mail server, you actually have to link code into it so that you can store a database procedure, and it can understand the procedure call that's sent to it. You do this with the Open Server Toolkit. So what you do is you disturb your existing email environment in order to implement the solution. We're saying, no, don't do that. Simply do it through an application and use the standard X.400 mail protocol from your application. So all I'm saying here is there might be some advantages with a Sybase approach because it's more automatic, but there are disadvantages in that you have to actually disrupt your email environment.
This might be a stupid question. Wouldn't the rule kick in if you're using rules on the Ingres side? You fell below inventory.
Well, the problem is that we can't initiate an event in a non-Ingres server through a rule. So you can set up a rule so that when a condition occurs, you can change data as a result of that condition occurring in an Ingres database, but you can't, as a result of that condition occurring, send mail to somebody. We don't support that today. We actually are looking at supporting that type of feature in our 6.5 release of the server, and that feature will be called database alerts. So then when an event occurs through our rule system, and a server will be able to post an alert to a process such as send mail to the following user based on that condition. So we will provide a Sybase type solution. But today we have a way of doing it through an application.
Eric, your no automatic, what does that mean, no automatic?
Well, what I'm saying is that it's the Ingres solution requires you to handle this condition through the application. So you can't have your server automatically send mail to a user when a condition occurs, like inventory falls below 10 for a certain table. We don't support that today. So our solution here is not automatic, whereas theirs is automatic. But the disadvantage of theirs is that you actually have to disturb your mail server and link in code to your mail server, whereas in our solution, you don't. And remember, all we're trying to do here is neutralize what they're saying. They're saying this is a great advantage, and what we're saying is, well, maybe. Neutralize it.
Isn't theirs though not quite so automatic? Because if you've got an application where if inventory on a certain group of things falls below something, I want to send an email to one person to do this. So you've got to write code and link it into the mail server. But if you had a second application that said, when somebody leaves a department on an employee application, I don't want to send mail to somebody else to do something else, wouldn't you still have to write new code and link?
Absolutely. Absolutely. Yes. So All I mean by automatic is that once you write it, it's automatic. But you're absolutely right. If you want to do anything different, you have to recode again. That is true of the Sybase solution across the board. Anytime you want to do something new, you have to recode. Anytime something changes in your environment, like the location of data changes or user operations change, you have to code a new procedure.
So couldn't we kind of just diffuse it by saying it all depends on, the big difference is just where it gets coded? For us, it gets coded in the client application. For them, you've got to code it into the mail server kind of thing?
Well, you have to do coding in both cases, although I think there are some advantages to having it coded into a server, but maybe not. I mean, you could argue that. And that's exactly what you want to do here. You just want to raise these objections to neutralize what they're saying.
But if you start coding, again, if you change it in the client.
You want to just, it's a client. That means somebody has to go in and say, okay, do this. Go send this mail message off. I mean, or if you do the
Then you
other.
lose your client-server architecture.
Well, all I'm saying is if there's any data that goes to the server that causes that event to occur, then it's automated. In the sense with the client interface, it's a user-driven event as opposed to a data.
Well, it can be, it's application-driven. In other words, you can have your application, you could have a daemon process set up, which just occasionally checks the status of a inventory level on a table, and based upon the result of that query, does something like send somebody mail. It can be a daemon process. So you can automate it.
Management there, though, basically, where you program in the business rules. I mean, the business rules are automatically.
You cannot use the knowledge management feature in this case because we don't have the ability to, upon a condition within the database, cause an event in a non-Ingres server. We don't have that capability today. We will have that capability. So unfortunately, you can't.
With OpenSQL, when you're writing applications and you want to do your plug and play in a Ingres application, so like a DB2 database, how do you know if you're writing OpenSQL? Is there a check?
No, there's a document
Okay.
which tells you what the guidelines are for OpenSQL.
There's no way to tell if you proved that you did something that was for Ingres.
Not really, no. Okay, let me move on. So all you want to do here is you want to neutralize what Sybase is saying is an advantage. Now, the other thing that you want to do is set the agenda, the industry agenda, against Sybase. Sybase is non-standard. Drive this into your customer's head. Sybase is non-standard. They don't provide you SQL access to distributed multi-vendor data. They're asking you to use this Sybase proprietary database procedure approach. That's not the direction the industry is going. And we can provide you lots of press releases, et cetera, which indicate this. And yes, this is one of the reasons we went out. I went out actually on the press tour and announced SQL Access with Roger Sipple of Informix and Jeff Balboni of DEC, strange bedfellows. And one of my motivations was to create resistance in the market for the success of OpenServer. Because what we're doing is we're pushing SQL as the standard way to get to distributed multi-vendor data, not database procedures. And actually enough pressure has been put on Sybase that they eventually had to join SQL Access. What we're doing is quite different from what they're doing, so they have to change their solution quite a bit to be SQL Access conformant. Puts them in a bind. Okay, they are non-standard. Their database procedures are proprietary, have nothing to do with OSF, RPCs. They have nothing to do with industry standard SQL. Just set this in the customer's mind to create resistance to their whole approach. And then set the Ingres agenda. There's a long list of things which we do which Sybase cannot do. And make Sybase sell uphill against our agenda. Convince the customer that they have to have dynamic SQL access to data. It's not sufficient just to have pre-compiled database procedure access to multi-vendor data or distributed data. You have to both have ad hoc query capability through dynamic SQL and pre-compiled support. And we support both. We support pre-compiled through the fact that OpenSQL supports a construct called repeat query, which allows you to pre-compile a query. So if you know what you want to execute in advance, you can do it in an efficient way. Fine. And Sybase can do that, but that's all Sybase can do. We also support dynamic SQL. You've got to do both. They only do one. We have a solution that's based upon industry standards. Okay? absolutely have to provide global optimization. Did you know that Sybase doesn't do this? Doesn't provide any global optimization? How are you going to get data from multiple sites efficiently? Are you going to have to figure out where data is within your application to determine the quickest way to get it? And what happens when the location of data changes? You're going to have to recode your application? That's not good. The distributed database management system should automatically determine where data is located and keep track of its relative distribution. That's what global optimization is about. Sybase doesn't do it. And Sybase does not make it easy to manage distributed data because they provide nothing like a star view tool that works with a global data dictionary. They don't even have a global data dictionary. All they have are a bunch of local dictionaries. And furthermore, with their whole database procedure approach, you're actually referring to the location of data explicitly within your database procedure. What that means is if the location of your data changes, and you have 10 database procedures and 10 different servers which refer to the location of a table in a certain database on a certain node, and you change the location of that table or that database, you have to recode all 10 procedures. Can you imagine, when you think of combinatorially, the mess that this is going to create? Sybase is an extremely hard solution to manage. And finally, even Sybase's long-touted solution, two-phase commit, is not much of a solution because you have to do all of the work of coding the two-phase commit protocol yourself. When we provide automatic two-phase commit. And if anything goes wrong, if a coordinator node fails or a participant node fails, if a computer, network, or database failure, with a Sybase solution, you have to write all the recovery code to get your data at multiple sites back into a consistent state, whereas Ingres Star is doing all that work for you. So what's so great about this Sybase solution? So back to our agenda of unification, distribution, and management, the whole solution, how does Sybase do data unification? What's the equivalent of a distributed query in the Sybase world? Well, what it is you have to write a procedure and store it in each of the databases whence you want to collect information, and have a procedure in one server be coded to call procedures in other servers which collect information at each of those sites and download the information to the first site, and then perform a join there. In other words, you have to code a bunch of procedures to essentially batch download all your information to a local site. That's not a distributed query. You should just be able to send an SQL query to your distributed database management system and have the database management system do all the work of determining where the data is located, determining the quickest way of how to combine that information, and sending it back to you, the user. You really want to do all that work? And this business about database procedures. Well, as far as I'm concerned, database procedures are dangerous. And the reason they're dangerous is because they don't operate under transaction control. In other words, it is possible to write a procedure which debits somebody's life savings at a remote node, run a transaction at your local node which executes that procedure somewhere within the transaction, then have that transaction roll back at your local node, and guess what? It doesn't automatically roll back the effect of the database procedure. So, oops, I didn't really want to debit that person's life savings, oh well. The bottom line is database procedures don't execute as a part of a distributed transaction, and therefore they're dangerous. They don't have any distributed transaction control.
I don't understand. You said they had two-phase commit programmable, and then you just said that they...
Right. That's a different feature. That is a different feature. What they have is the ability within their application to code the two-phase commit protocol to execute a distributed transaction. What I'm talking about is the fact that database procedures, if you're running a transaction at your local node and you execute a remote database procedure from your transaction, and then you later roll back that transaction, the effect of the remote database procedure is not undone. So now that's it. So the message here is that remote database procedures are dangerous because they're not executed under distributed transaction control. There is the two-phase commit feature separate from database procedure support. in Sybase, programmatic two-phase commit, which allows you to, in your application, secure multiple databases and update them all or not update them. And even that is no good because you have to program it, and because Sybase is providing no recovery management capability with their two-phase commit implementation. Yeah.
A similar scenario, this might not be part of this discussion, but I think it's just a yes/no answer. If you did a database, if you did a call to a database procedure on a local node and then did a rollback, would it back out locally? Or is it only when you go remote that it won't do the back out? The rollback?
No, you would have to explicitly undo the database procedure.
No,
So
no matter whether
it
it's
doesn't matter what
there
node
or
it's on.
someplace else.
Database procedures, when you execute a procedure, it does what it does. If it updates information, it updates information. If you then roll back your transaction, that,
procedure's still going.
right, that's correct. Okay, we talked about database administration and the problems that you have to recode your procedures at each node anytime location of data, for example, in your network changes. So this is quite messy, involves constant recoding as your data environment changes. Okay, I'm getting near the end here. Let me talk quickly about Informix. The bottom line is Informix only provides access to Informix data. They do not provide gateways today. They are working with a third party to provide what they call gateways, which are really file extract tools. So their answer to getting to corporate-wide data is they're depending upon standards maturing quickly. They're depending upon the SQL Access Group and to rally the standards groups to get all vendors to implement a common SQL and common client-server protocol so that you won't have to buy gateways, at least for relational access, so that you can simply buy an off-the-shelf Ingres tool, Informix tool, and off-the-shelf Oracle database, and the tool will plug together. Well, it's not clear when that's going to happen. And that essentially results in a situation where Informix is telling you to wait for standards. They don't provide gateways today. They are working with a third party to provide file extraction tools so you can get data out of VSAM and IMS and download it into an Informix database. They provide no two-phase commit capability whatsoever, programmatic or automatic today. And they have a distributed database product. It's called Informix Star. It only works with Informix data. And it's architected such that it will not work with non-Informix data unless they completely re-architect. I used to work for Informix. I actually worked on the project, which is the basis of their distributed database called the Turbo project. What Informix did to increase their speed is they essentially rewrote their database management system to bypass Unix buffer cache and file I/O, use something called raw partition on a disk. Okay, so that bought them some performance. However, what it did is it locked them into hardware. So it makes their product very unportable, and it makes it very Informix database specific. So they are now have an architecture. Their Informix Star architecture is such that it will lock them into providing only access to Informix data unless they change their architecture. Informix is quite active with the SQL Access Group, but we have yet to see any interoperable products produced by the SQL Access Group. We are making progress in SQL Access. It's unclear when commercial products will be available, and the other thing to remember is that SQL Access is great, but it's delimited. It's a delimited solution because the whole SQL Access effort, this will come up in some of your accounts, the SQL Access Group, is focused on providing interoperability between relational databases, between SQL databases. SQL Access is not even working on the problem of providing SQL access to non-relational databases like RMS file systems, as we do. And it's not working on the problem of providing access to IBM data because IBM is not a part of the SQL Access Group. Therefore, what SQL Access does for Ingres essentially is it endorses our entire approach in the market of providing SQL access to heterogeneous data. But it doesn't in any way, our solution essentially engulfs what SQL Access will come up with, because we provide SQL Access not just to other vendors' databases, which someday we may be able to do through SQL Access without gateways, but we also provide SQL Access to IBM and to non-relational databases. So that's the best way to talk about SQL Access if it comes up in an account. It's good, it's positive, it shows that SQL access, not database procedure access, is the way to go. We are based upon the same sort of standards SQL Access is working on. However, we have a much more comprehensive solution, because unlike SQL Access, we also get to non-relational data and IBM data. So, in a nutshell, all of our competitors are vying for the same business of providing access to information throughout an organization stored in different vendors' databases at multiple locations. But the bottom line is, Oracle is talking about futures. They don't have the product to provide that access today. They will provide some of the capability in their next release, and it's not clear when Release 7 will really be available. Based upon their history, Release 6 was a couple years later than originally promised and about 10 times slower than originally promised. And given the recent budget cuts, the story for Release 7 may be even worse. So they're talking about futures, and you should make this clear to customers that who knows when we'll actually see this stuff. We have it today. Sybase, their story is open server. Build it yourself. Well, that's a lot of work. And furthermore, what you build doesn't give you ad hoc query capability. It only gives you a predefined capability, and it's a hard solution to manage, because not only do you have to build it, but you have to constantly rebuild it. Anytime anything changes within your environment, you're going to have to recode all these database procedures. It's hard to manage. It's costly and it's hard to manage, and it's dangerous, because it's based upon technology which allows you to do stupid things like not be able to undo effects of a distributed transaction. Informix's story is basically, well, just wait. Standards will mature, and gee, they're maturing awfully quickly. Just around the corner, a year, well, maybe it's 2 years. Well, maybe it's 3 years, actually. Well, maybe it's a little longer than that. But just around the corner, vendors' products will interoperate automatically. You won't even need gateways. Well, the problem there are two problems there. First of all, they're not providing customers with a solution. They're asking them to wait for standards, and how long can customers wait? And secondly, the standards that they're asking them to wait for don't even provide a full functional solution. They're not going to provide them a distributed solution. They're not going to provide them access to non-relational data or IBM data. So why wait? Everyone has a story, basically. We're in the position where we actually have products, and more of these are coming available to you. We are in the privileged position this year of actually having products which customers, not futures, not standards, not toolkits, but full functional products customers can install into an environment and provide users with online access to other vendors' data and to distributed data today. So that is what I have to say. I'm glad to entertain questions. We're now slightly over time. If you'd like additional information, you can look in VAX notes. There's some information in Connectivity Newsletter and Star Wars notes that I put out. And you can always contact myself or Kathy Hessian, who's the product manager for Ingres Gateways. Okay. Thanks. Okay. Do we have time to take some questions?
Sure.
Okay.
Eric,
Yeah.
this might not relate to this, but how long has Oracle been saying they would come out with Release 7? Is it a year, 2 years?
It's been almost a year that they've been talking about Release 7.
Is there any idea of when that is going to come out?
Well, the projections I've heard is at the end of this calendar year.
Beta?
I'm sorry?
Going into beta in this calendar year?
Well, the projection that I heard was FCS at the end of this calendar year, but given the fact that they are not even in beta, I doubt it.
They're not in beta right now.
No. Yeah.
From the standpoint of a number of customer opportunities, we've been posed with the question, do you have an Oracle gateway? And, you know, there's been a lot of different answers that I've heard in the 2 months that I've been with the company. But let's say, for example, we had an opportunity that represented 5,000 licenses, or, you know, it's a fairly large opportunity, spans the whole organization. They have Oracle databases around that they don't necessarily want to lose the time they spent there. But we don't necessarily want to propose that they rewrite all that in our own database server just because of the costs that they would have to pay for that. Is there a position that the company would take in regards to an Oracle database?
Yeah.
That's
Well, okay. We have a position. And the only thing I can say is if you have a customer that needs an Oracle gateway, then get them under non-disclosure. Okay, we have something to tell them. Okay, but we do have a position now. We waffled on it for a while. We have a position.
Pete and Dave, let's talk offline. I can tell you more about that.
Right.
That's fine. Do we have a gateway toolkit?
We have a gateway to an SQL gateway toolkit.
What is that?
That means we have a toolkit which, if the business opportunity is appropriate, allows a customer to build a gateway to a relational database. We do not have a non-relational.
That is SQL based?
Yeah. No, you can build a gateway to another relational database. We have no toolkit for non-relational databases.
Well, I thought when I said SQL based, meaning that the interface for that other database would have to be SQL
Yes.
in order to accept those.
That's correct.
Could be a relational one, no SQL interface.
It would have to be SQL, and it'd have to be a business opportunity which is lucrative for Ingres, and the person to determine that is Kathy Heschen, who's the gateway product manager.
Okay. Thank you.
Okay, thank you very
Thanks,
much.
Jack.
Okay.